On this episode of the Tech Junkies, RFID, RFID, and more RFID. We'll be showing you how to build your own RFID reader to use in dorms or apartments, and also how to impersonate others by cloning your own RFID tags. So grab your Arduino, here comes another episode now. Thanks for tuning in to episode 8 of the Tech Junkies. This is our RFID episode, if you couldn't already tell. I'm your host, Eric, and today we're going to be doing some pretty cool stuff with RFID. One of those things being an RFID reader for your apartment or dorm room or some other place where you can't have a permanently attached RFID reader, but you want to have RFID access for wherever you're living. So I've gone ahead and designed this little circuit here using Eagle, and of course this schematic will be provided on the website for anybody to either make, or maybe we'll get together a group order if we have that many people interested in it. But really this just takes a little Atmel AVR micro that goes in here, and then also just a few other small components like capacitors for filtering the power, voltage regulator, and best part, spot for a servo. So when you plug in a servo, you simply use that to actuate your door lock, and that way you don't have to install anything into your actual door. We're just going to be using things like double-sided tape to actually hold your servo to the door and rotate the lock. Now, one of the other cool things we want to have in this is have it be able to detect when the door is open and closed, which is where this magnet will come in handy. We'll be using a magnetic prox sensor. So you'll have that mounted on the inside of your door, and then this will be mounted on your door frame. So when your door opens, it knows that it's open. When it closes, it'll automatically lock. So that'll keep it, you don't even have to think about security at that point. You close the door, it locks automatically. So let's get started and start building this thing. So first I want to go over some of the components that are actually going to go into this build and everything you're actually going to need. So we'll start off with the actual servo. This is just a high-tech HS311 standard servo. These are available at pretty much any hobby shop. About 10 bucks a pop, and you should get some nice little attachments with it. Some might be easier to mount to your door lock, but really you'll just choose whichever is best. And this just has a standard 3-pin female header on it, so we'll be connecting this to our board. Now for the reader portion, this is a Parallax serial reader, and this guy is about 40 bucks. It's a little bit more if you want to buy it with some sample RFID tags, which I've got here, which I'll show you in a second. But the way I've wired this up is I've got a wire going to VCC, and this is just the 5 volts that you're passing from the main board. We've got the enable pin, which is soldered to the ground pin, which actually permanently enables this, so there isn't really a reason to disable it. And then we've got serial out, so that feeds the serial data from this into our microcontroller. And then we also have ground, which goes back to our main board. So you can either use this, or if you already have an HID tag, this is an HID reader. I've also written some code samples that use this instead of the Parallax reader. And this is a little bit different. This talks through 2 different pins. One is when it gets a 0, and when it gets a 1 from the tag, you have a different data line for each one of those. It's a Wiegand protocol. So we'll show you how that works in the code samples later on, but this is only if you already have, like, let's say an HID tag issued by your company. This is pretty handy to get. These are a little bit more expensive. You're going to get about 150 bucks retail for one of these. I was lucky enough to find one used on eBay for about $50, so look around, see if you can get one, and otherwise we'll just be using the Parallax reader, because that's the way to go if you don't have any RFID stuff already. Now we also have this little prox sensor, so you'll need to get some sort of magnet. I would suggest something fairly strong so that it picks it up even if it's a little distance away. So this gets mounted on the inside of the frame, or on the outside of the frame, and this will actually be mounted on your door. So when the door swings shut, this detects the magnet, and then these 2 wires are shorted, so that'll get passed into our microcontroller as a switch. And then I also have a tiny little switch right here. You might want to use like a Staples Easy button or some giant button, like a dome button, to put on your door to actually act as the door release, so that way you don't need your RFID card to leave the room. So let's say if you have guests and they want to leave, they can just hit the button and that will open it automatically from the inside. We've also got a 6-volt regulated power adapter. This is just from Radio Shack, but really any regulated supply will work. And you want to make sure it's regulated, because if you have something that says 6 volts but it's giving you 7 or 8 volts, it's going to fry some of the stuff we're using. And the reason we are using 6 volts is because this servo is what actually uses these 6 volts. Now we also have one more thing that you need to program the chips. This is a USB Tiny ISP, and we'll have the link to this in the show notes. And this is what we're actually going to use to program our chip. So this just takes USB in, so you plug this into your computer, and then this comes out as your programming cable, and this will plug into some headers we've got on our board that I'm going to show you now. So if we take a look at the actual board, you can see we've got the PCB here, which we'll be providing the Eagle files for if you want to tweak it or you know, do whatever you want to it. And then we'll also be providing the files so you can just send this to a board house and have it manufactured and you don't have to touch it. If you do decide to go that route, we'd suggest using batch PCB, as they've got really cheap prices, about 15 or 20 bucks, and you'll be able to get, you know, 2 or 3 of the boards shipped to your house. So it's really cheap for low quantity boards. Now some of the other components we got here, just some screw terminals here that we'll be using to feed the wires into, so it holds it in nicely. These are available on sparkfun.com. We also have a little tiny voltage regulator here that will bring the voltage down to 5 volts for the microcontroller. And then also some header pins for programming for the servo, and some filtering capacitors. These are just 47 microfarad capacitors we'll be dropping in. And then this is just a 20-pin socket and an ATtiny 2313 Atmel AVR microprocessor. Of course, we'll have this whole parts list on the site, so you won't have to remember any of that, because I'm sure you probably didn't. So if you also look down here a little bit, we've got the sampler pack. I don't know if I have all the tags here, but this is these are some of the tags that came with the Parallax RFID reader. You see you got this nice big world tag. You've got the standard 99-cent tags you can carry in your wallet. Keychain's pretty nice for your keys, and I like this little dime. You can carry it, you know, even in your wallet or whatever, back pocket, really whatever you want. But it costs a few extra dollars. You know, you get the sampler of the different RFID tags, so you can really decide which one works best for you. Okay, so the board is soldered up now, and now we just want to put the ATtiny microcontroller in. So I like to bend these pins down a little bit on the edge of a table like this. And now we should just be able to insert this guy right into the socket, and always make sure your key matches up, little notch. So we'll just drop this in here. Push down, and there we go. Now your microcontroller is in the socket. So your board should look something like this. Okay, so now we're going to go over how to actually get the tag off of your RFID tag, or the tag value off of this. So like this doesn't even have anything printed on it. So you've got your RFID reader, your Parallax reader, and this is another thing you can get. This is just an FTDI cable. This is basically a serial interface to USB. There's actually a little converter board inside of here. If you have an Arduino lying around, you can also do the same thing with the Arduino. All we're trying to do here is talk serial to this guy. So I mean, even if you had a serial port on your computer, I know it's probably pretty rare, but if you did have that, you would be able to use that. But this is just a bridge, so we can actually talk to this directly to our computer. So this talks at 2400 baud, so you'll need to configure whatever program you're using. I would suggest just downloading the Arduino software and using the serial monitor built into that. You can just set the baud rate to 2400. And all we're going to do is, I like these header pins. These are pretty cool. You're going to connect the black wire, which is your ground. You're going to connect the red wire, which is your 5 volt. And you're also going to connect the yellow wire, which is your data line on here. So you'll want to either solder this up or somehow connect this up so that you've got your 5 volts going to the VCC. You'll have your yellow wire on here going to the S out, and you have to make sure your S out is also, your ground is also connected to your enable, so that it actually enables this for reading. So you have all those wires connected up, connect this to your PC, go to 2400 baud, and then just wave your tag in front of the reader, and your tag should pop up on the screen in front of you, and then we can program that into the code. And now you want to take your USB Tiny ISP, and you'll see you've got the programming cable. This programming cable should connect up like this and point outwards. So now you're ready to program it once you're in this stage. And you don't have to connect this to your 6-volt adapter unless you're actually testing it with the servo. So this guy will power the whole board, and you can program it just like this. You don't have to connect your power source. Also, make sure you've got this little jumper in the USB Tiny set, because this will power it through the programming cable. That way it will power up and then you can program it. So let's get to programming. So you've got your USB Tiny ISP connected to your computer, and now we just need to set up the software on your computer. Now this is going to differ a little bit between operating systems. As you can see, I'm using a Mac here, but it's pretty close to for the differences between each operating system. So particularly for OS X or on a Mac, you're just going to need to download this software called Crosspack, and this is just the tool chain that allows you to compile code for these Atmel AVR microprocessors and actually download the code. So this includes everything you need all packaged up. Just install it and you're all set to go. On the Windows side of things, you're going to want to check out WinAVR. Same sort of deal, contains everything you need. Just download it, install it, and you should have all the software you need on your computer. And then on the Linux side of things, all you need to download is this AVR libc, which you should be able to find in your package manager, as well as AVR Dude, which is the software we're actually using to download the code to the chip. And also, if you're on Windows, you're going to need the driver. Now this does work out of the box with Mac and Linux, but if you are on Windows, you're going to want to come up to the Lady 80 site, and we'll have a URL to this on the site so you can get to this. But all you need to do is install either Windows 7 Vista or XP driver, and you should be all set to go on Windows. So when you connect it, it'll detect it and everything will be good, all good and happy. So let's start the programming side of things now. So I've got this folder. This will be up on the website of the actual source code for the unlocker. And I've just got two files in here. One's called lockv01.c and also the make file. So you should have your tag that we got just a second ago. Make this a little bit bigger. So this is the actual tag that I'm going to be loading into my unlocker. So you just want to open up this .c file. Make this a little bit bigger so you guys can see as well. And I've got this section right here. Tag value goes here. All you got to do is take your value that you obtained from your RFID tag and just drop that right in there in between the quotes, and then save the file. And you should be all good. This should be about all you'll need to do. The only other thing I could foresee you maybe needing to modify are the delays for the servo rotating. So if you come down here a little bit, you probably won't need to touch any of this, but you can see in here you've got the delays for, you know, how long to wait for the door to unlock, for the door to open, along those lines. You can come in here, change it, play around with it, you know, whatever you need to do, but for the most part this will probably work for most people's needs. So make sure you got your value in there, save your C file, and that should be all we need to do. We'll get rid of this. And then your make file actually specifies this file name, lockv01, and it also has instructions on how to download the code. So you really don't need to do a whole lot. Just by typing make at a command prompt, you should be able to dump this code straight into the microcontroller. So make sure you've got it all connected up, your USB Tiny is plugged in, set to go, and then in the Windows you would do this through command prompt, and Linux, you know, terminal or whatever you've got, but I'm just here on the OS X terminal, and I'm in this directory right here, the lock directory. So there are my two files, and all I have to do is type make, and you'll see compiles it, and now it's writing the chip, and there we go. It read it back and said that it verified that it all wrote correctly, and everything's all good. So if that happened for you, then you should be all set to go. All right, so now you should have code on your microcontroller. So now we can go ahead and disconnect this. Set that aside. So now we need to wire up all of our components. So first thing, servo is very easy. You just want to look right here, and you've got the G, which stands for ground, plus, which is positive voltage, and S for signal. So your yellow is your signal, so just make sure that gets connected in like that. There you go. Now you just have to mount this on your door and attach it to your lock. Up next, we want to connect the power supply. And if you haven't already checked this with a multimeter, you want to verify which one is positive and which one is negative. And you can see there's a plus 6 volts and a negative on the board that will tell you where you're connecting that up to. So we'll go ahead and screw this in. that's tightened down now. Now up next, we want to connect our parallax RFID reader. So you've got your VCC, your ground, and your serial out. So now here on the far left side of the board, you can see you've got the plus 5 volts, the negative, and the RX. So those are the 3 that we will be connecting to our RFID reader. So there we go. Now you got your RFID reader connected up. So up next, we just need our 2 sensors, our door release and our magnetic prox sensor for when the door is open. So you can see here on the right side, you have a negative for ground, you have a DOR for door, and then you also have RLS for release. So your release is going to be your push button or your Staples Easy button or whatever it is that you've got. And then your DOR is going to be your door sensor that actually gets mounted to the door. So 2 of these wires just get twisted together and connected to ground, and then the other 2 will get connected to their respected connections on the board. And that should be everything you have to do to get your door setup working. Now you notice we do have a few other connections that are not wired up here. You also have the TX pin, and that's just added for future expansion, like say if you want to have this guy talking to another board, that'll be for sending data out of it. But right now that's not implemented. And then you also have the in0 and the in1 pins. Now this is relevant if you're using one of these HID readers, as instead of wiring up a serial pin here, you'll actually be wiring up your red, no sorry about that, it's the white and the green wire are your 2 inputs, so your 0 wire and your 1 wire. And you'll have to double check that on the schematic for the HID reader. But you connect those in there, and then your red wire is the 5 volts and your black wire is ground. So that's how you would connect your HID reader. But we're going to continue covering the parallax setup. So at this point, double check all your connections, make sure you don't have any polarity reversed or anything. And we will try powering this up. Alright, so we've got it powered up now. So you want to grab your magnet, throw this in front of the prox sensor, and then if your servo wasn't already in the lock position, it should already rotate there. And now we're just going to grab our RFID tag that we programmed in and wave this over the reader, and then pull the magnet away. So this should now be in the unlock position, and then this symbolizes the door being open. So as soon as the door closes now, it should go back to its lock position. And there you go. Now we can also try hitting our door release button. There you go, manual open, door opens, and then close again. And you notice I also put in a little bit of a delay. It's about 4 or 5 seconds before it tries to relock itself, and that just gives you time to open the door, walk out, etc. But that will be customizable. You can go back and change that in the code if you would like. So overall, I mean, everything appears to be working. You can use your RFID tag, and your magnet prox sensor is working great. So now we'll move on to the next thing, which is cloning RFID tags. So now that you built your RFID reader, we're actually going to try and clone a tag and impersonate another user. Now you already know the method we used with the parallax reader and the FTDI cable to actually get the code off of one of these tags. So you're going to have to be creative about how to actually get this tag from the other person. Maybe borrow their wallet, maybe, I don't know, hide this reader in your pocket and try and get close to them. I don't know. Be creative. You have to figure out how you're going to get the tag from them. Once you do have that code off their tag, then we can start building your own cloned tag. So the way we're going to do this is with one of these @Tiny 85 microcontrollers. And we seem to like @Mel chips around here, but they're pretty handy. So we need to build a coil that connects to it. So I've got this magnet wire here from Radio Shack. It was about $7 for this whole pack. And I believe it's 30 gauge wire is this red looking magnet wire right here. So that's what we want to use. We're going to wrap it about 100 times. We'll show you that in just a second. And then we're going to connect it to only 2 pins on the microcontroller, and that's it. That's all you're going to have connected to this microcontroller. And you might be wondering, well, how are we going to make this work with only 2 pins? Well, over at scanlime.org, they had a really ingenious way of doing this. It's a little hacky, but it works. Where you actually have your reader giving power off of it. So this is sending out, electromagnetic power, and we pick it up with the coil that we make. So that's going to be connected to the clock pin on the microcontroller, And every time this pulses, this is pulsing at 125 kilohertz, it's going to clock the microcontroller 1 cycle. So that means that we can program this to be exactly in step with the reader and send data back, or basically tell it, I'm a tag, and try and impersonate that other tag. So we've got the code off scanline.org, and we're going to show you how to program that in just a second. But the basics are there. We're going to build your 100 wrap coil about the size of an RFID tag, connect it to our microcontroller, and then once this is programmed, you'll be all set to go. It'll be all soldered together. We'll tape it up a little bit, and then you should have a fully cloned tag that you can then use to impersonate that tag that you got. So now we actually need to program this little microchip, and the first thing you're going to have to do is build a programming cable. Now this is kind of just tacked together, but this is just a perf board I'd line around, and all you need is an 8-pin socket. This is just a 20-pin socket. Really doesn't matter as long as you have those 8 pins. And this schematic will be up on the site, but all we're really doing is getting a programming header for actually programming this microchip. So this will pop into the socket, and then you're going to use your USB Tiny ISP that we had from earlier, and just plug this into your header pins right here. And we'll actually want to bend these pins in a little bit so it actually stays in the socket. So pop that in there. So now we should be all set to program this. So let's get to actually building the code, dropping in your tag of your target, and writing the code to this. So now it's time for the fun part of actually loading the code onto this spoofed RFID tag that we're building here. So you've got your USB Tiny ISP connected all to your computer again, and you should have your @tiny85 all set to go in your programming cradle. And you're going to want to get some code here off of scanline.org, and this is some pretty cool stuff. If you want to read through this article just of how they actually pulled this off, it's pretty impressive. But if you come down here to the bottom, you've got this latest AVR RFID source, and you've got this make file and the avrfid.s file. So you download these two files, and I just place them on my desktop in a folder called spoof. And I'm also going to provide this write commands.txt file, and this will be up on the site, as well as a link to Scanline's page on this. And this should be everything you need to load up this card now, or the spoof tag we're building. So once again, you should have your tag that you somehow obtained. I'm not going to ask you how, but this is the tag we're going to clone. And, this was the tag that we used earlier for the unlocker. So first thing you want to do is load up avrfid.s. Make this a little bit bigger again. So this is just explanation, don't really need to pay attention to this. If you scroll down here, you can see the first thing is defining the actual format of the card. So if you're using like an HID card, then you could actually spoof that as well. We're using what's known as an EM4102 tag, which is the same thing Parallax uses for these sorts of tags that we've been playing around with. So we're just going to leave this as is, but if you did want to play around with the HID stuff, you would uncomment that and comment that, but we'll leave that as is for now. So you want to come down here to this EM4102, these two lines, and this manufacturer ID is the first 2 digits of your code. So you're going to grab these two and just copy them right into there, and now grab the rest of the tag and dump it right into there. And that's all you need to do. So you can save this file, and that's everything. It's that simple. So, whoops, get rid of this. Don't need you. And the make file should be set up, all set to go, so that once we type make, it'll automatically compile this. And then I've also put together this 2-line file. I don't know if you can say put together, not a whole lot here, but these are the 2 lines we're going to use to actually flash this to the chip. So first things first, come in here, and we'll change directory into spoof, and there are our files. So you just type make, and there we go. Everything appears to have compiled properly, so we don't need terminal anymore. Actually, we'll need terminal in just a second. But now I have this .hex file, and this is our actual program file that we're going to be writing to the chip. So open terminal back up. Don't know why I got rid of it. And oh, already here. Okay, cool. So there's the hex file right there that we're going to write. And this might differ a little bit on which operating system you're on, but it should be the same for the most part using AVR dude. So I'm going to go ahead and copy this in to my terminal. And all this is going to do is write this avrfid.hex file onto the @tiny85 chip. Hit enter on that. I'll just enter my password here. And there we go, writing, and then it reads it, makes sure everything turned out good. So it's all set, everything verified properly. And now this next line, you want to be careful with this because this actually sets the clock of the microcontroller to the external pins. So once you do this, you won't be able to reprogram your chip unless you get some sort of external clock source up and running, which I've never actually done, just because once I usually flash these chips, I don't end up reflashing them. I end up clipping off the pins to make it all nice and clean. But if you did want to reprogram this chip after running this command, you'll need to get some sort of clock source like a crystal or some sort of oscillator. So just be warned that once you do this, you won't be able to reflash the actual code of the tag without getting that clock source. So we run this command now, and this will actually modify what they're known as fuse bits on the microcontroller, and this kind of controls a lot of the settings of the chip. So before we just wrote code, like our program, to the chip, and now we're actually modifying the settings that govern how the chip is going to run. So this is modifying, you know, a significant piece of the microcontroller in the fact that you won't be able to reprogram it now, and it's separate of the program. But we go ahead and run this, and there we go. It wrote the fuses, and it says they're verified. Everything looks good. But now, let's say, oh, I want to try flashing this again. You'll notice we'll get this error, initialization failed. This is because it's now looking for a clock source on those 2 pins. And remember, that is going to be provided by the actual RFID reader. So it's not a problem here unless we need to reprogram it. But we need to change this so that it will actually be right in step with the frequency that the RFID reader is running at, which is 125 kilohertz. So that's all you need to do, and your chip should be all set to go. So let's jump into the next step. So now you've got your code on the chip, and we can go ahead and disconnect this. And we're just gonna pop our chip off of here, just like that. So this is what's going to act as your tag. Now we need to wrap our coil. So I'm going to use this 30 gauge magnet wire that we got from Radio Shack. And what I actually like to use for this, I'm sure you can probably find a better way if you have a board or something lying around or some screws, but I just had a perf board from an old project here. And all I did was measure out 3 inches by 1.5 inches. Seemed to be a pretty good tag size for me. So I just got some little tiny screws that fit into my perf board here. I just screw those into the 4 corners. And about 100 wraps around here is pretty good from just testing what seems to work the best. So that's what we're going to go for. It doesn't take up too much magnet wire. In one of these Radio Shack rolls, you'll probably be able to get a good 4, maybe 5 tags out of all the wire. And you can use the different gauges. It's just I've had the best experience with the thinner gauge. There we go. And now we just want to get the wire out. And you want to leave a little extra, about that much. We'll come back and clean up in a second. And you might want to get someone to either hold one side or tape it down. So I'm going to grab a little bit of electrical tape here. And just cut a little piece off here. Yep, just make sure we've got this little bit of extra there. And basically start wrapping, and don't lose count. Okay, so that was about 100 wraps. I'm gonna go ahead and cut that off now. And we just want to take out one of these screws, just like this. And I usually like to take some electrical tape and wrap it around one of the sides. That'll actually hold all the wire in place before we completely take it off here. And afterwards, probably just wrap it or you know, get some sort of adhesive or liquid electrical tape or something that'll hold it all together nicely. But you know, wrap one of these sides, unscrew another side, throw a little bit of tape around that side, just like that. And this is coated, so we will need to scrape off a little bit of the enamel on the ends of these two wires. Probably just throw one more piece of electrical tape around here, just to hold it all in place. That's your basic coil that's going to be used to basically impersonate the other tag that you collected. So you've got your two ends coming off here now. And just get a knife or something you can use to scrape off this enamel. You'll probably want to roll it around a little bit, make sure you get it all off of there, just on the ends. And then do the same for the other wire. So now you should be able to solder these up to the chip, and you should have a clone tag. So, bring the tag over here, and you notice you have your little dot here in the upper left. We're going to be soldering to these two pins right below that one, and it really doesn't matter which one is which, it's just the clock signal, so you can just solder any wire to any one of those pins. And I honestly don't even reuse these chips once I program them. So I like to go ahead and clip off the excess pins first to make it a little bit easier to solder. That way you don't have all this in your way. And then you've just got your two pins exposed there. So now let's solder our coil to it. And at this point, you should have successfully cloned the tag. And you know, you can wrap this magnet wire in like this and tape it all up and make it a really nice clean tag just by wrapping more tape around it or getting like some sort of liquid electrical tape. But that's really all you have to do, and you should have a completely cloned RFID tag just by doing that. So go try it out. So hopefully you learned a little bit more about RFID and exactly how it works. And now you've got your reader for your dorm room, your apartment, or wherever else you need to get access to. And you can also clone other people's IDs and, you know, do with it what you will. Knowledge is power.
And knowing is half the battle.
And we'll see you next time on the Tech Junkies. Woo!
What if for each intro to the Tech Junkies, the green screen background was different tacky footage of disasters? And you just never, I mean, just never, no matter how many people say something
like
about it,
like comments and stuff, for the one.
Never, like, I mean, you don't see it.